Hi, everyone. Welcome to session 2 of our machine learning mini series, total of 4 sessions. You have here Achinkya, Prakash. Nidhi will join soon as well. Let's give everyone a few more minutes to join the session before we get started. Yeah, I hope you enjoyed the first session. Also, every one of you who couldn't attend the first session, we have the recording. We shared it via email, so you can watch it again or rewatch it anytime. Maybe say quickly hi in the chat if you're there. While we're waiting for more people coming in. So hi, good to see you. Hello. Yeah, for everyone who is new, who hasn't attended the first session, we are Data Driven Science, an AI training company delivering trainings in machine learning, also soon deep learning, via different channels, doing that on through webinars, what we're doing right now. We have done webinars before, but also working on more comprehensive online trainings in form of online courses that will be published soon. All right, hi. Good. I would say we can get started. I think more people will join over time. So I'm going to hand it over now to Achinkya, who again will lead this session. Yeah, I wish everyone a good hour and a half. And if you have any input, questions, feedback, please mention them in the chat so we can either respond to them right away or get back to them later. All right, I hand it over. Enjoy, everyone.
So let me share the screen and make the screen full screen. Okay. So last time when we began the session, it was all around 7 stages framework, and this was the document which had been shared. So if this is the link, if you want to just check it out, because we'll be using the same document here as well. Okay. So what had we seen? We had seen the stages, and we actually completely try to understand how this thing goes, wherein starting from problem, collecting the data from it, then we go to data preparation, data visualization, then feature engineering, ML modeling, and then finally production. So this stage from 1 to 7, and in the exact manner when we go from start to finish, this is exactly how stuff happens. So if we go on kaggle.com, now what would really help for everyone to get actually selected as data scientist is you actually doing this for real companies. Okay, so if you go for companies, and if we check in the competitions, you will see there are a lot of competitions which are here. Many of them are research, and many of them are also a problem statement a company has actually put forward. Okay, so if you scroll down here, it will be a good exercise to just go through all the competitions here and think, okay, which one is really relevant to a business, which one is really not, which one is just in the beginning. So when you do start, yes, I will share the link. So when you do start doing this, first we need to know is check these categories. Okay, so on Kaggle, let me just take a screenshot of this. These are the categories. So let me just copy paste these categories here. Okay, so now going forward, we are actually starting with the coding part. And for the coding part, you need to know have few things. Okay, So just a second. You need to have coding problem. You need to know coding syntax, and it's like problem to solve. So problem to solve and coding knowledge on how to solve. These are the two things which you need to kind of like actually go forward. So which coding problem to solve? This is gonna be on Kaggle. Okay, so this is where this document, this image kind of like comes into picture. Let me just paste it here. Okay, and let's see, can I put it on the, not this, not this, not this. Okay, let's it's fine. So we are going to go to Kaggle competitions, and in the Kaggle competitions, a good way to start with playground. Okay, so start with playground, but aim for either recruitment or masters or with prizes. So start with playground, but aim for recruitment, master, or with prizes. Okay. So this is the kind of like aim you should be having. Let me just put bullet points here. So this is the aim. You start with the aim, and then this is the how. Okay. So first is the coding knowledge, and second is the how. How do we solve that problem? So we are going to learn this, and also going to always be referring to where we will be using that knowledge to solve the problem. So in the course which is upcoming, it's this is how the approach will be. We'll have the how and also where. Okay, and on the session one, we thought about the why. At every stage, there is how to do it, and the thought process about the decision. So thought process about the decision under constraints. So these are the three things, when you use together, you are actually a complete, a good, knowledgeable data science person. So Prakash, he has worked on a lot of projects. So Prakash, out of these three things, problem is of course a simple thing. You will be working on a problem in company. Now, which one do you think is more important? Knowing how to solve the problem versus knowing how to choose a decision amongst trade-offs under the situation. How frequently do you consider trade-offs under constraints?
Yeah, yes, Ajinkya. Thank you for the question, and I would make it quite straightforward. The trade-off for choosing the decision is very important because again, how to solve the problem is something we can get to know by studying, getting to know the sessions and all. But somehow this trade-off decision is specific to the problem, business statement, and what are the expectations for an organization also. So this trade-off decision under the constraint is really very much important and crucial, and that makes a real data scientist in the market.
Exactly. So, in many of the courses, so everyone who is joined now, if you can just think about the thought process and framework which you will use to find out the choice of your final decision. This is what we need to do. So, what do I mean by thought process and framework here? Is you actually can't simply just know remember one answer. For example, if you are working on, let's say, image processing, you can't simply say for image processing cnn's are the only way. So that what you have done is like you have remembered just one answer, but that's not how it is. You have to know, I mean, if the problem changes, what if then you'll have to find the answer and remember it for that problem. It's much better to have a framework to find answer to any problem. So thought process and framework, so that you can find out the answer. So by using this, you can find out the choice. And this is, then these are the options here, like Prakash just said. There are trade-offs, and these trade-offs are under constraint. For example, if you are a startup, you might not have, let's say, enough money to train a lots of experiments. If you are a new developer, you might not have in-depth knowledge of highly optimal libraries. If you are, let's say, a big data person, you might not have a machine learning knowledge of the libraries part. So there are a lot of things. So we need to know the how and also the thought process in finding out kind of like what is the choice and how do you find out. How do you find? The answer is extremely simple. It's like you try and see the output. This is how the foundation of entire science is. Okay, foundation of science is experiment. It is hypothesis, then experiment, results, and revised theory from observation. So this is how the foundation of science is. And how do how do you find the answer? Okay, the answer. So this is the foundation of science. Okay, by hypothesis, experiment, revised theory, and blah blah blah. And as you can see, there is science word in data science. This is what we will be actually following. So try, see the output, see what works, what doesn't work, and then go back. Okay, going back to the problem here, I said aim for getting start playground when you start, then recruitment or masters or with prizes. So here, let's see, I am going to select a playground competition, and let's try to find out a interesting competition which we will use as an example throughout. Okay, throughout this next 6 stages which we are going to see. So, guys, feel free to mention in the chat which one do you think is more interesting. So, open images, this is for deep learning. Deep learning, so that's not the course which we are doing. Deep learning is going to come in maybe 6 months. So, this is not, we can't see this. Then, photo slideshow optimization. Again, this will probably be in deep learning. This probably will be in deep learning. This is in playground thing, categorical feature encoding challenge. So this is a feature encoding challenge. So probably again, not a machine learning problem. So revenge of accountant. So this was 7 months ago. Sounds interesting. Let's see. What is the problem statement here? Santa was thrilled community minimizing bookshop cost. Calculus were adapt. Unfortunately, North Pole accountants were not pleased. Uh, mm, okay, I don't know what this problem is trying to say. I mean, it is a very vague thing. So what is the family data? 206 KB, file descriptions, workshop preferences, this thing. Okay, I don't know what this problem is. So Kannada MNest, not this one, encoding, ciphertext, wildcam, cactus identification, don't overfit. Ooh, this box office prediction. This seems like a simple enough problem for us to do. Or don't call me Turkey. PUBG. Maybe people might like this. Can you predict the PUBG royal finish of PUBG players? Let's see this. Taxi fare prediction, store demand forecasting. That's also definitely ML problem. What's cooking, movie reviews, donor challenge, whale identification. This is image, spooky author identification. Taxi trip, then we have goblins, transfer learning, dogs, leaf classification, sequence learning. Okay, these are quite old ones, so these are not the interesting ones. Okay, so let's finalize one competition out of these. Okay, movie, this thing you are presented with metadata, include this thing you collect. Do do I feel lucky, punk? I don't know. This is a dialogue of Dirty Harry. It is quite popular dialogue. So, predicting which movie will be hit or not, predicting which. Okay, so it's like, what is this? There is this data. So I think you can choose one of these, right? This seems like a very interesting thing. Total of enemies. Ah, right. Okay, so those who are gamers, they can choose this one. Those who want to go into retail can choose this one. So I think these three are a good short listing to do. So let me just choose this and put it into the document. So what are the problems which we are going to see? Problem statements. One, either box movie prediction, whether a movie is going to popular or not. Two, PUBG, if you are into gaming, who is going to win. Three is demanding demand in a store or something. Okay, so here you could be doing this. Say, let's say, how has the demand changed according to COVID. Okay, how will demand change post-COVID unlock, post-COVID vaccine availability? Okay, so you see, these are the kind of like problems which you can, solve with this kind of like data. You can showcase your profile and actually get a lot of traction in future. So yesterday I gave a session. The session was about what are the hurdles to getting hired. So in that hurdle parts, I just talked about what do many people do. I mean, they just focus on the knowledge, but they don't focus on what are the hurdles which they need to cross to actually, get hired as a data scientist. So we are going to include this in the course which is going to come, but I do recommend everyone to check this video out as well, which I've just pinged on the chat, and I'm going to also see is like hiring hurdles. And this video is that video here. I'll put that video here. Okay, so do check this out. And now, out of these problems, you choose the one you are interested in. So let me just replace this URL with this, replace this URL. Why is it not asking me to replace the URL here? Yes, and okay, and maybe this. Okay, it's okay, becoming hireable. It is asking me this thing. Yes. Okay. So going forward, now let's go for what we are going to see today. Okay. We have almost 1 more hour today. And in 1 more hour, we are going to take a look at essential stuff of 3 stages: data collection, data preparation, and then we have the final thing, which is data visualization. Okay, so we are going to see the basics of that. We are going to see the coding part. We are also going to learn how to use documentation. Okay, so what do we need to learn? So what do we need to learn? We need to learn this one thing, and how to use documentation, and how to use the function in the problem to solve the competition. These are the 3 aims. Okay, these are the 3 aims which we have today. Okay, so on the chat, I would love to hear how many of you guys have done hands-on with data collection, data preparation, and data visualization. How many people have done hands-on or participated in competitions, have gotten rank? If you can let us know in the chat, I will be able to, include those things accordingly in the session. So can you just let me know in the chat? How many people have done coding or no coding thing? Can you just put on the chat? Let's. I'm monitoring chat. No one has replied yet. Okay, fine. So I'll not wait any further. Okay, so Akshay has done the coding part. Good. Who else? No coding experience, coding experience. Okay, started learning to code, Aditya. That's good. Done data collection, cleanup, mergers, but in C++, Abhishek. Oh, that's nice. You chose a different language and now you will appreciate Python's power. Haven't covered visualization, Venkatesh. That's good. So your development knowledge will definitely help you. We will do the conceptual part of the data visualization, data preparation, and also possibly data collection if needed. Okay, so going forward, going back to this. And Sonali, it's great that you have R knowledge as well. There might be some companies where R might be used, but I would really recommend uh, to actually follow this thing. Python and scikit-learn. That is a lot more common ecosystem, and I really think that this is how you should be kind of like focusing on. Python has anyways crossed R, let's say, in its popularity, and Python is actually the default way going forward. So moving from R to Python is a good choice. Now, Let's see. What do we need to learn? We need to learn these things. Each library has a role and stage where it can be used, how to use the documentation, and how to use the function in the problem to solve competition. Okay. With this in mind, let's go for stage 2. Stage 2 is data collection. Now, what were the problems we are talking about? Box office prediction. PUBG finished the final placement prediction. Then we have this is demand forecasting challenge. Okay. Now these are the kind of like three problems. You choose just one out of them and start thinking about how do you collect the data relevant to these things. So let's do the discussion on the document. Okay. So data collection discussion. So this is the discussion part here. Now what I would love is like ideas about where you can collect data from. So here, please put in, just log in, open this document, and here, how many people are online? There are just 4 or 5 people online. So everyone can open this document, which is s.gd IVH. Okay, I have given right access to everyone to this document. Okay, and it's Yan will ping it in the chat one more time. So here, think of these problems: box office prediction, predicting who will win the PUBG thing and what will be the top 10 ratings, and store item forecasting. So, with these three problems, in the discussion part, think of places where you can collect the data from. Everyone choose their own problem, just one problem, and think up of places where you can collect the data and type it here. Type them at this place. You can, this is where the collab will go. This right here, everyone. Okay, so I'll give you few minutes to write stuff, and then we will discuss the places and we'll talk about the coding part of the data collection. Okay, so let me just start a timer. I'll open this tab. I'll leave this tab open. Please put in all your ideas. And if you have a specific problem you want to work on, you can also put that here. So let's give 3 minutes and start. And in detail, put stuff in detail, which social media feed, how can you collect the data from that social media feed, does it support the data collection? These are the things you need to think about. If that data is publicly available or not, this is also you can think. Okay, everyone's brain muscles are being flexed. Good. Wow, we have such amazing names. Someone is Badger. I mean, on Google, everyone is given an anonymous animal name. Dolphin. I envy the person who is been titled Dragon. Then we have someone who is Python. Very suitable for the work we are doing right now. Then we have Wombat, Rabbit, Beaver, Hippo, and Quokka. Not active. Okay. 1 minute. Cool. Cool. Wow. The Starcast publicity part, Badger, whoever is Badger, I like how you're thinking. Okay. So, social media feed, example like Twitter or LinkedIn or Facebook or what else? Instagram. Now, the only possible thing is Twitter, not anything else, because only Twitter has exposed the API of every tweet being posted on Twitter and even Reddit. Even Reddit. Twitter and Reddit. So on Twitter, there is a professional stream API which kind of like gives you live details of all the tweets which are happening in the world simultaneously. Okay. If you go for a free version of that API, 20% of all the tweets which are happening live, they will be given to you for free. So if I see, live internet stats, this will actually tell you how is the internet stats happening per second. Right now in a second, what is happening on Twitter? Around in a second, 9,000 to 10,000 tweets were sent. Okay. So 20% of this, so around 2,000 of tweet are freely available for everyone. If you pay for a full version, then all the tweets which are happening, they'll be available to you. You can use that data to do quite a lot of things. And I really love this idea of Starcast and the publicity of the Starcast. For example, here, let's say The Rock. The Rock has amazing social media presence, and how is the social media activity of the person has a huge impact on the movie, and it will make a huge difference to the movie box office collection. So these data can be collected. Now the transaction tables and all this is like probably not available publicly. Probably it's like these sites don't make available, how many tickets have been booked, but the Starcast detail, the publicity thing, trailer likes and dislikes, this you can definitely extract. Okay, I don't know what is Sadak 2 movie. Let's check. Sadak 2. 4% like this movie. One on IMDb. What is this movie? I mean, that's the lowest rating I have ever seen. Anyways, so so we have repeated searches on internet, again not available because only the search engines have this data. Box office predictions, we can definitely do this based on, there is this thing. So box office details, this is a website which is quite interesting website, where they not only give you details of how much a movie earned, but they also give details of for how was the stat of box office earning details. I used to follow that website quite a lot. I don't think Box Office India, this thing, VP. Yeah, the numbers. Yes, I think this is the website, the numbers. Yes, found it. Okay, so let's see. Let's search a movie which is Suicide Squad. Oh, Black Panther. I mean, sorry that actor died, but okay. So this performance, domestic box office was this much, international box office was this much, worldwide box office was this much, the domestic DVD sales, Blu-ray sales, and total this thing. If you kind of like check details here, you will see all the records. Okay, if you scroll down, you should be able to see mm, full financials. Oops. Oh, they have made it. They have hidden them. Damn it. Previously, this was public. When I used to use this website, it was, public. So now, okay, we at least have just these things, division country wise and blah, blah, blah. Okay, you have these things. They do have weekend performances, daily performance. Okay, this data is available. So this is quite enough, more than enough to do a lot detailed information prediction on what a movie might perform like. So the genre of the film, the publicity of the stars, and all the details which like you had mentioned here, right? So you kind of like think, oh, what are the places where you could get the data from? What information is actually quite necessary for you to understand a relevant data and blah blah blah. So then you start with the actual content. So you think of this. Okay, you think of this, and then you start with the actual content, like actually scraping the data, actually collecting the data. Okay, so the words like simply scraping is like they are quite ambiguous if we don't mention what are we scraping, right? So the actual content is like this now. So we have two kinds of library for everything. Remember when we were talking about 7 stages, we had POC and then we had production. In POC, we test how good the model is, if it can make money or save money. And if that is true, then and only then we can, let's say, actually just finalize to go to the production. Okay, so this is POC and then production. Okay, so the libraries in the POC phase, one library called as Beautiful Soup, other library called as Scrapy. You could also say there is this thing which is Selenium. It's also used in data collection. The phase of data collection is quite infrequently used. Hence, we are not going to go into details of all of these things. We'll just stick to Beautiful Soup, simple thing, okay, and not go beyond it. Now, when you're going to production, you need a lots of data at an extremely large scale. Then you use this library called as Scrapy. It's what web search engines use to crawl through the entire internet. So it is distributed, and I think you can probably use this especially in Twitter to collect all the data or something. Okay, now going back to learning Beautiful Soup. So we have started the coding part. Okay, we have started the coding part, and let me just showcase the code. Okay, so the showcasing code is the 7 stages V1. Here is this 7 stages code. Okay, so let's think up of each thing and we will incrementally increase the complexity. So now we are into this part. Okay, so let me just copy paste this and paste it here in the 7 stages part here. So this is the 7 stage, and now in the coding part, oops, does it not have a code? Is Nidhi here? Beautiful. Just a second. Let me just find out how I can paste a code in a better manner. Just a second. There is a place. How I'll paste the code which is easily readable. Okay, just a second. Give me. Okay, so carbon.now.sh. So this is the place. So carbon.now.sh. I'm going to have this thing, syntax. I'm going to have Python. Okay. So let's copy this code, paste it here, and now export as image. Or maybe, hopefully, this should also work if I just paste it like this. Up, not really. Okay, so the code is like this. I've just put in stages as an image. Okay, so we have pandas and numpy we simply import, and we have created a function, and I have just created an empty function. So data collection, data preparation, data visualization, and rest of the stuff is going to come in future. Now going forward to data collection part, and I'm going to teach you how to kind of like do use beautiful soup, what are the essential functions, and then we will go forward to actually giving you an assignment, rather maybe not assignment, maybe I'll call it homework. Okay, so that you can do that thing on at your own time. So going to beautiful soup, and what are the essential functions of beautiful soup? Now let me go to the library itself, beautiful soup documentation. Okay, I'm here. So any help you might want about the library, you need to just go to the documentation. Okay, so beautiful soup documentation is this, where all the details of this entire library are available here. Okay, now we don't need to know all the functions. Okay, so as you check on this page, it is insanely big. Not all functions are needed. Not all functions are needed. So we just need to know is, maybe I'll put it here, most frequently used and needed functions only. So we need to learn is like most frequently used and needed functions only, and refer to documentation. Let's say this is the fourth part. Now, what is the beautiful soup and what is the most frequently used function? The most frequently used function in beautiful soup, which is most needed. So we are actually going through the coding part of data collection, then data preparation, and if we have time, data visualization as well. Okay, so we are now at the coding part of data collection, and for data collection we are taking a look at beautiful soup. So for beautiful soup, our problem is, let's just say this: I want to plot a graph like these, and I want to see how is the division. Okay, maybe I can plot in a detailed manner. I can say how's the performance and how the ticket performance is going to be, details like this, right? So let's just copy paste this, and the data collection, try on this. Okay, so this is the website, which is the numbers.com, where you can actually extract daily performance, how it happened, and details like this. Correct. So maybe we can create a dashboard like this, and we can showcase how much power is that movie going to have on DVD sales or Blu-ray sales or something. Okay. So starting with the code part. So I am going opening this, and let me just open data collection tutorial. Okay. So we are starting with the code. Exciting. First thing you need to know is what are these four things. Okay, soup, tag, attribute, and function. Okay, so what is soup? Soup is nothing but a place, rather let's say container of the HTML document, which we will use to call to extract the information in the page. So if you have this numbers thing and you want to extract the details of, oh, how much was the box office details every day or something like these, you can simply download this HTML page. You can't call any function on HTML page, right? So you need to use soup. On soup, you need to call then functions, which will allow us to extract the information from the page. Okay. That is the first thing. Is what is soup clear? Can you guys let me know in the chat, yes or no? Is what is soup clear? Are you clear about what is soup? Yes, no? Yes, no? Okay. Thanks, Aditya. Thanks, Venkatesh. Cool. So, how is the example now? The example is, I'll show with the example one more time. You have a HTML page. Okay, what is this HTML page? This is the HTML page. If I simply press Control U, this shows me the source code of the page which I had opened for Black Panther, right? So this is the source code, huge source code, right? Now I can read this HTML into the soup. Soup is what? Is nothing but variable. So this is the format in which you use beautiful soup. Okay. So let me just go to carbon dot this thing. Let me just paste the code here. Okay. And let me just show a function called as, let's say like this. That's it. That's it. Okay. This kind of like finishes basic stuff of our this thing. So let me just say size 3x or 1x, and let me just do export. So let's see, where is this image? Has it opened? Okay, it is opened. So let's export it one more time. And okay, this is what you do. Oops, this is not a high quality one. I think I'll change it to size 2x and maybe change it afterwards. Anyways, so this is available on the Beautiful Soup official documentation. So don't worry, you don't have to save all of these things. All you need to know is this documentation. And that's it. Okay. So what do we want to do? So we get a page. Okay. So how do you save the page? A page you can save by using this thing called as requests. Okay. So let me just showcase the example. Okay. Yes, this is how you can. This is how you can do the code for this thing. So from import request, and then page is equal to this thing, and then you say URL. That's it. Whatever your URL is, you first import the request thing, and then you simply say page equal to request.url.get. Okay. So we will do the demo. Okay, we will do the demo here. So let me just say maybe create a new code block here. Import request URL. I'm going to put it like this. URL is equal to this request and execute. But its import is URL. Okay. So if I just print page, wait, dot HTML, I guess, text, I guess. Yes, yes. So this is how it is. So the entire HTML source code of the page has been saved here. Okay, so this is how you first save the entire data. Okay, this is how you first save the entire data. So let's see, Control A, Control C, paste it into the carbon. Okay, and done, right? So export here and paste it here. Okay, so you start like this. import requests URL, you get it, and then you call the appropriate functions to get details. For example, let's say if you want to get the details of, let's say, what's the title? Okay, so this title is detail of what is present in the HTML page. I want to get the title of the HTML page. So I'll say soup.title. I'll get the title. So let's see. I'm going to see new page. I'm going to say page.title. And let's see. It does not have a title. Epic fail. Okay. Then let's see. There is no title. Then maybe soup.p. Is there any soup.p? Oh, there is no P here as well. Oh, stupid. What I'm not doing is like I have not created the soup. Okay, I have to create soup out of this thing on which I can call the function. So this is the thing which I did not do. So let us just do this. Soup is equal to beautiful soup. This is the doc and I'm using HTML parser for this. And I'm going to do soup.p and soup.title here now. Oh, I have to execute this one more time. Oh, I did not import beautiful soup. So many problems. Okay. The response has no length. Okay. I don't know what this guy is doing. Maybe I'll just do request dot this thing. Okay, I don't know why what my environment has I think failed or something, because these two are different ways. You either use request package which is present internally, or you use URL lib.request. So what I'll do is like I'll find out what is the problem. I don't have time to debug it live because it will take time. So let's just skip that. Okay, let's just focus on using beautiful soup thing here. So the function, how do you access elements, is you simply call soup.findAll and get the details. Okay, here let me just find out daily box office performance. So I'm doing right click here, clicking on inspect. Oh, right. Thanks, Akshay. You're right. I have to do it as a request. Anyways, so I'll do it. I will not kind of like go back and debug it. But for now, let's just progress a bit further. Okay. So you see, there is this division whose box name is box office chart. The ID is this. On that, we have a table. Okay. Table does not have a name. Table has this body which is like contains first date, rank, gross, income, year detailed, and then theaters per theater, blah blah blah. Then we have rest of the details here. Row number one, row and row details, row number two details, row number three details, and we have stuff like this. So every row here is corresponding to a source code, and where we have details like how much money we have, something. So I could extract details of a movie performance easily by using this table, right? So what do I need to do? I need to find out all the rows. The problem is there are a lot of rows here. So there is this table, then there is another table, and there is another table. So first, I will execute and find out this section. So on beautiful soup, let's see what is this. You see, if I click on div, it contains everything. Okay, so I don't want this. I'll do inspect here and let's check this div. So you see, this division has a ID called as box office chart. So I could do beautiful soup find all. Or maybe restart fix it. Request.get. I did declare, but anyways. So page, HTML parser, URL is correct. I don't know. So you guys figure it out. So you just do it like this. Then you call, what do you call? You say find all with the ID of this div being box office chart. Okay. If I scroll down, let's see what are the details of this. This is also box office chart. Ah, okay. So if I do find all on box office chart, I will get everything. So I need to find out there are three box office charts here. Okay. Yes, there are three box office charts here. I need to get the second number. And that is how I think probably the pattern will be for every movie table here. Okay. So you will get the second division, and on the second division, you will do find all for table rows. And then on the find all of every table rows, you will extract each column, and that is how data collection works. Okay, so we have this thing tutorial in which I have put in all the details of how you can do find all and how you can extract the information. So let me do one thing here. Let me just upload this file. Let me just upload this file. Where is download? Export notebook as maybe HTML. And let me just save this file into the data collection part here. Oops, not supported. Okay. So what do I do? Let me export it as PDF, LaTeX, etc. Markdown. I will just try it. Execute script. Yes, PDF. Okay, let me try it as PDF. Okay, I don't know why. I think my entire environment has gotten corrupted. That's why I'm facing problems for everything. I mean, I had run this just yesterday, but there is some problem. Sorry for that. Uh, but okay, let me just. I'll share the data collection file. Okay, I'll share the notebook of data collection thing. We'll share it on GitHub or something. That is about actually tells you for data collection. Okay, so I do want you to extract. So try the coding on this part and extract details of performance per day of movies in year 2019 versus movies in 2020. Because in 2020, post lockdown, what has changed is something very curious to see. What is the movie which was recently released in lockdown? Box office, let's check daily chart. Domestic, this thing, see full daily chart. New mutants. As you can see, none of the data is present here. So I think we just need the details of the 2019 movies. So this is the homework. Extract the details of performance every day of movies in year 2019. And that is your homework assignment. I will put in the code details here. Just, after our session is done, let me just find it out. Okay. So that was our data collection. Sorry, there was problems while doing this. We'll fix them and I'll upload the exact code here. Let me move to the data preparation part. I just want to take a few important functions, talk about the libraries in data preparation, how to use the documentation of pandas and numpy, and then we should be able to end for the day, and data visualization we can take in the next time. Now, Let's go back to Kaggle. Let's go back to here. So I am going to open PUBG now because its data is huge. It is around 1 GB worth of data. There are 59 columns. Okay, there are 59 columns here. So let me just agree to the competition rules and check the how is the data. Okay, so the data is okay. We have ID, match ID. We have this thing. We have boosts which are used, damage dealt, assists, and a lot of interesting thing, right? Then we have DBNO. I don't know what this. Ooh, headshot kills, heals, kill pace. Wow, there are so much data here, right? So, oh, let's me just do it column wise. Let me do column wise. Yes. Okay. So we have details like this here. Okay. So then, what else do we have? What else do we have? We have other columns, integer. How many integer columns do we have? Oh, yeah, it is like this, right? So here you need to check a lot of details. How many rows or values are missing here? How many are unique? How many are common? Is there any mismatch? Is there any different data type which is present here? Is something integer and something float? If there is a date and time, what time zone is the date and time? Generally, we never think about the time zone because we just exist in our time zone where we are there. But communicating across locations, you need to agree on a standard time. And time zone as a concept was invented in US when raid roles were put into USA. Okay. Before railroads were put in, what was happened was, people used to just check by, sun has come up and sun has gone down, and rail train is fast. So then people realized ki, oh, you can't actually make it by just checking sunrise and sunset. That's when time zone was invented to make a standard communication between different places possible. Same thing is true here. You have to kind of like take a look at the data, m- put it into a proper format. Okay. Now the problem is, most of the times on Kaggle, all the data is actually very good. Okay. But in reality, it is not that way. Okay. So if I just show, there is a tweet which was my favorite tweet, that talks about, in reality the data is extremely messy. It says that, whenever there is data is messy, data is not clean, you need to spend at least 4 or 5 months juggling with the data, getting it into a good format. Okay, so that's what we are going to do. That's what we are going to see how to do in pandas. Okay, let's see. So going back to the point, while we are into the POC phase, what is in POC phase? You are just doing proof of concept. You are not working on the final project. You don't have huge data. You want to, with help of libraries, quickly see if it works or not. You don't care about optimization. You don't care about performance. You just want to get things done. Okay, so for that, we have pandas, NumPy, and Spacy, and OpenCV. So these are the kind of like libraries here. And the most common library is generally pandas. Okay, so we'll use pandas. Then if you are into production phase where you have just decided that, okay, I know this is profitable, I know I'm going to put it into production, then I just need to do same thing on extremely large volume of data, not in numbers of GB, but in terabytes, maybe even more than terabytes. At that case, we need libraries like maybe Dask or PySpark or ETL tools or data warehouses. This knowledge will be needed when you are working as a data scientist, and that too when you are working on a deployment of the project. But generally, while you are learning, you need to know pandas and numpy. These are more important. If you want, libraries for doing data preparation in field of NLP and computer vision, then Spacey and OpenCV are present. Okay, so going to pandas, let me just talk about essential function of pandas, and then let's finish for the day. Okay, before I do that, I just want to ask a question. In the previous stage, I mean, we just had 1 hour series, right? So uh, the question is in the data collection part. I know there was problem in the syntax. I'll sort it out and next time share the details. In the syntax part, what would you like to see in the stage data collection? So people who are live, 19 people, can you let us know on the chat what would you like to see in data collection in a video which is teaching data collection thoroughly? According to your feedback, we will include that into our final content. So think about what I tried to cover. I mean, not what failed, but what I tried to cover. Think that I'll make a very detailed content on this. In that content, what would you like to see and what would you like not to see? Can you put that on the chat, on the YouTube chat? Because it's very useful for us. We'll use that to, fulfill your demands. So let us know. I'll wait for a few minutes and then move to the pandas. So what would you like to see or not see in data collection, which is stage 2? Feedback, feedback, feedback. Feedback, feedback, feedback. Anyone? Okay. Such a quiet activity. Okay, cool. Thanks, Shekhar. Thanks, Akshay. So data abstraction and mining collections. Okay. Maybe thought process. Oh, good. Akshay, that's good. I'll include that. We do have that for this thing, but good as a reminder. Good, useful. So Akshay's point is good. We are including that. What else? What else would you like to see and not like to see in the stage data collection? And if you got an idea about how we will be approaching the final content, would you suggest some changes? I'll just give maybe 10-20 seconds and then move forward. Yes, Sai. Brainstorming, correct. Okay. So good feedback. Now let's move to the data processing in the pandas part and let's see. Now we are in the data preparation stage. Most likely the data always is messy. Data is many a times with lots of problems. And you have to kind of like put that into a format which can be used by the machine learning model. So the most time consuming phase is data preparation. So if we take back, go to these 7 stages, the most time consuming phase is stage 3. It's not an intelligent work, but it's a lot of work. Whether the data is small data or whether the data is big data, it doesn't matter. It is still, excuse me, it is still extremely time consuming. Okay. So data preparation and the library which we are going to see for it is pandas. So in pandas, let's just take a look at the documentation and learn how to use the documentation of pandas. Kung Fu Panda. So here, more than user guide, more than getting started, more than developer guide, API reference is what you should be actually using quite a lot. Okay. So in the pandas, this is the API reference. Here, it will list all the functions which are present in the pandas, and I will just talk about which functions out of more than 400 functions present, which ones are important, which one do you need to know. So I have shortlisted the stuff. I have gone through the entire this thing, and I have just given a few functions for you guys to master. Okay. So the first thing is, let's go into input and output, and which one do you think are important? Or rather, I know which are important. I'll talk about them. So first is reading a CSV file. And when you open it via documentation, this is how the documentation is present. Okay. It talks about parameters, what parameters are present. Then you need to actually open documentation, check the parameters, see what do they mean, so that you can use them properly. Okay. So we have this. Okay, so lots of parameters are present here. And just the example is this. As you can see, it's just pandas.read CSV, and you say CSV file. If I want to read an Excel file, let's scroll down. How do you read Excel file? Oh, okay. This is how you read Excel file. You see pd.read Excel. Then you give the Excel file path. You give index. So this just reads column, first column. I read to read and write access. I want to read a specific sheet. Okay. I could read everything, just headers and blah, blah, blah. So all the examples of how to use read Excel is what you need to master. Okay. So this is how you actually should be, using pandas documentation. What we have is like everything here can do something which is useful in a specific role which it is playing, which is generally now data preparation. Okay. Scrolling down to data preparation part, let me just disable document outline mode. We just increase zoom. Okay, and let's go for this. So we have few functions: read CSV, read Excel, and read table. Okay, then we have data manipulation functions. Okay, so data manipulation functions, and these are actually, every function has a role. I mean, which stage it is useful in. So this is in data preparation. This is used in data preparation. This is also used in data preparation. So you see, I'm copy pasting data preparation, data preparation, data preparation. This is also in data preparation, 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 as you can see, like this. Okay. Now, this is not just data preparation. This is data understanding. You need to find out, oh, what are the columns? What are the data types? What is how the info is there? What are the values? What is the shape? And then you have again data preparation. You see, this is how it happens. Okay. So going back above, you can do merging of two separate files together according to a certain thing. You can do join. You can create a thing called as get dummies. So what is get dummies? Let me just talk about here. This is present in general functions, and this is the get dummies thing. So what does get dummies do is, if you have categories, you see A, B, A, B, C, C. So if you have words or categories, it converts them to numbers. This is used in feature encoding. Data preparation, other word is feature encoding. What is feature encoding, blah, blah, blah. That's kind of like a different thing. We just need to know that it is used in data preparation, but the exact how it is used in feature encoding, that will be covered in the feature engineering. Okay. So what does join do? Join joins, pivot table. Pivot table is able to create a permutation and combination of across two tables. So for example, if I go here, let's say Black Panther thing, I want to do, I want to find out how much was the net income of the movie over weekends and over week. You see here, it just gives me the box office performance. I want detail. I want detail like how much is the money made on Sunday and Saturday versus the rest of the week. If I find out a movie is making a lot of money on just weekend, maybe I can change how the theater is playing that movie in the theater. If there is a movie which is making money during week as well, we can make more shows during the week and reduce its shows on the weekend. And for a certain movie, we can have more shows on the weekend. Okay. This is the data driven decision making is what we are talking about. And to do that, we need to have a proper charts. So in Excel sheet, there is this thing called as pivot function. So finding total gross per day, per theater or something, all such kind of like permutation, if I want to do, I need to use pivot table. Okay. So this is where pivot table actually comes into picture. So that's pivot table. Then this is the missing data. I mentioned data is never clean. The problem on Kaggle is on Kaggle, data is always clean because they kind of like clean up, not completely, but they do clean up a lot of things and give it to you. Okay. So if I go to train data and I send column wise here, so it will see not much missing, not much mismatched, not much this thing. You have details like these here. This is how the histogram is. This is how the values are distributed, blah, 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 blah. Okay. So on Kaggle, you don't have to do this quite a lot. But if you do data collection, if you are actually working on a real company problem, then you have to do this quite a lot. Okay. So this is how the reality is, to be honest with you. So let's ask Prakash. Prakash, you have worked on chest X-rays and other products, right? So how much time did you spend? How did you do missing data and conversion like thing? What are your thoughts on this?
Yeah, that's a great question actually. And if we ask and this question and allow me to answer, honestly, then any problem, not on the medical side, but any industrial problem in my experience, almost 70 to 80% times we just invest into the data. And when I say the investing that much of time, it means understanding the data, making it to in a certain state so we can utilize into the example, because no data is ready for experimentation and specifically for the business problem we wanted to solve. So it is always the data preparation where we look at the data, and it is not just we clean the data, organize it into the experimentation, but back in the mind, when we look at into the data, we do understand it more closely, and it help us to design a better machine learning solution for it. So it is very worthful, and my suggestion would be to spend enough time in understanding this particular process of data preparation, cleaning, and making it to a usable for the machine
What tools have you used to do the data cleanup? I mean, is it just pandas or other libraries also?
See, I mean, for the record and textual, I mean, this kind of data where we have structured record, Panda is no doubt one of the choice always in the industry also. But when it comes to data in terms of images and videos, and it could be like a different multi-dimensional data, at that moment, choice of the library and framework does change. So it's not anything like very common, but we do use, if it is an images, then we need to work on a different aspect. Like we use OpenCV, we use, there are many open source solutions to understand the images and clean it and make it align, augmentations and everything. But if it is a structured tabular data, then yes, pandas is the choice.
And how frequently is SQL used then? Is SQL knowledge quite important in this situation?
See, I don't have a genuine response to that question, but in my experience, when I have worked on several problems where structured data was the input for the AI system, it was related to song lyrics, understanding, music recognitions. At that moment, yes, handling the data after the cleaning it up, we need to store and make it to be quite indexed, accessible. At that time, SQL is pretty much useful. And if it comes to unorganized data or the data which cannot be in structured and tabular format, at that moment, we usually choose a different kind of NoSQL DBs for it.
Perfect. So, having worked in
Yeah.
the field of this data science for almost a decade now, right, Prakash?
Yeah.
So almost a decade. That's the perspective I wanted you guys to have. This is the reality. I mean, I have taught a lot of people about in data science thing, and I have seen fewer production projects, but Prakash has seen them quite a lot. So the reason I was, bringing questions like these is to understand it's not just pandas. It's also you might need to know a bit of Perl. You might need to know a bit of Linux awk maybe. You might need to know a bit of SQL maybe. We have to understand that, oh, we want to do data preparation. For that, we need to do data cleanup. We need to find out missing values. How do we do that? I could do it using pandas or something else. Generally, people use pandas. Okay. So that was the kind of like my point I was trying to make it here. So going back to the this doc, Google Doc, going back to the important function. So we have, this is used in data preparation for dealing with missing data. Then if there are, data types which are not correct, for example, we have numbers, but they were into string. Or if you have string and there is some encoding problem or something like this, you need to transform them into its appropriate format. We need to get details about what is the data type, what are the values, what is the shape. You need to do some functions there. For example, these are the kind of like functions which are possible. Like, okay, if it is just numeric, I might need to do some power function, need to multiply some things, you need to find out maybe if it is in a matrix format, compare, find out determinants. These are all the mathematical functions. Okay, so pandas has all these things. So in the course, which is gonna come soon, in the course, we will go through all these functions. And because there is enough time, you can go through these questions in a proper allocated time. Today, we are just giving you overview. Okay. So overview of which functions are important. So we have using descriptive stats, we can actually understand how is the data distribution of the data you're working on. Core is going to find out correlationship. Are these two columns similar? Are they related to each other? That's what this finds out. Covariance finds out how much change in one thing leads to change in the other thing. So that's what core gives you, cove gives you. Then you have min, max, medium, mode. All these things just give you stats. Okay, now if you have, let's say this was what missing data, right? What do you do with the missing data? Do we replace it, or do we fill it, or do we delete it? So this is the drop thing. So let me just, this should be present here. So drop and drop duplicates, this should come here. So these are the functions which play this role into data preparation again. Then it's all into the missing data handling. Okay. So as you can see, with these functions, which are these are the grouper functions, these are the mathematical function. Then there are other date and time and string functions, date and time functions, and string functions. Okay, with this thing, pandas, these are the few important function. They don't exceed more than 20. As long as you go through them, as long as you understand them, you are actually, you have mastered this data preparation phase. Okay, it's similar thing which you can do in NumPy, but NumPy has very less features. That's why we just focused on the pandas. Okay, and based on the domain, if you're working on vision or natural language processing, then you need to use different libraries. So Spacey for NLP, OpenCV for vision, or you could use Patterns 3. A lot of choices you have, but the base is pandas always. Then a domain specific thing you might have. Okay, so this is how the data preparation important functions are. And now you can actually just try to use this for these problems. So these were the problems, right? Either box office prediction, PUBG thing, or store atom this thing. I would now be very interested in this problem, because this box office prediction, you can combine this data with the data from this website called as the numbers.com, and you can extend them and you can use them to do data collection and data preparation. And then in next time you can maybe also try data visualization as well. Okay, so I just talked about the important functions in data preparation phase. Next time, next Sunday, in data visualization, we are going to go into more details. We will, because there are only just 5-6 functions in data visualization. So we'll teach you syntax properly. We will teach you the meaning properly. We'll teach you how to interpret. We'll teach all those things in detail, which we couldn't do today because there is just too much to do in data preparation. I hope the overview was just opened your eyes, and it could help you just finalize what you need to master in pandas. Okay, so this is what was planned for today's thing. We focused on the coding part a bit more than compared to previous time. And similarly, in next 2 sessions, we will finish data visualization and ML modeling, and then feature engineering and deployment in the final one. So this finishes a complete overview of our 7 stages of machine learning in this 4-session series. So that's it what I had for today. Let me just stop my screen share, and now Jan can just conclude.
Thanks, Ajinkya. Before we finish the session, are there any questions? Is there anything that was unclear you want to go back to, or any feedback? So anything you have, maybe you can just send the message in the chat so we can address your question or your feedback before ending today's session. So everyone, is there something you want to talk about? You want us to talk about? Any other questions for Ajinkya, Prakash, or myself? How's Cinderella?
Oh, I think Prakash will be a good person to answer these things.
So one nice, one question I could see here is about the final data-driven result was wrong. So, okay, one interesting example I can give that every 4 years when soccer World Cup starts, football World Cup starts, so many organizations to showcase their strength and their power in the data science and machine learning, they always predict the outcome of the football matches, each match, and of course for the winner. And it is pretty much well known that most of the time their prediction is not correct. Although they use pretty much a good amount of data for all the football matches in the past, but they are never able to even the big companies, $1 million company does such kind of things, but the idea behind it is most of the time it gets wrong, and the reason being once they model the situation using past games of the footballers, but of course they have a limitation. Their result is data driven on the past and the history of the matches, but they are never able to incorporate the current situation. I mean, changes in the team and playing performance of every individual gets changed over the time, and weather, crowd, everything really matters, which they cannot model into the machine learning system. And that's the reason, even though they do it data driven work on that part, but it gets failed. So I thought this could be an interesting example to share here.
Yes, there are a lot of places where just because there is a lot of data doesn't mean you have a proper solution. So I just love the question because it asked for a counter example. And that's how
Yeah.
you should be thinking. Counter examples, whatever, whenever anyone says, okay, this is the best way, you always should ask that counter question. That makes you a much better data science student than anyone else, because now you
Yes.
are able to think. You can change the answer based on the situation. So love the question. Very nice.
And yeah, one more question is there, that big data technology is involved in data collection. For sure, it is. And there are many frameworks, I think Ajinkya already mentioned also. And because when we look at the data, when we are learning from the courses or doing anything on the other portals and all, it's like we do not think the data on it's a massive scale, but when it comes to the industry, data is always on a very big size. It's in a terabyte. So big data technology are intrinsic part of this whole data science pipeline, where we need to process the data in real time, more accurate manner. So yes, big data technologies are definitely a mandate for the data science pipeline.
Awesome. Cool. Thanks, Prakash. The other question I have answered. Yeah.
Prakash, maybe a follow-up question on this for you. Like when we think about small versus big data, for someone getting into data science, starting their career, how important is big data to actually be able to work in the industry? If you start a job as a junior data scientist or maybe an internship, is this something you should have those skills to work with large data sets, or how important do you think is it for a beginner level?
Yeah, that's a
data
very
scientist?
nice question. And we need to understand that a beginner cannot have like very less possibility that any beginner have a exposure to a large amount of data before joining the organizations or other institutes. So it is important to know about the perspective of a big data, how it works. And when we talk about the data science, actually there are many different roles, and there are dedicated people and teams working on processing the data, cleaning it up when it is a massive scale. So these are a different kind of skills, I would say. And coming to the point, if it is if we belongs to machine learning, artificial intelligence, so there we are more focused on modeling part. And but of course the person is the person who is doing the modeling is the person who know what kind of data is expected for a algorithm. So that's the reason Ajinkya has put a lot of efforts to explain how to clean up the data, how to process it. So it is very much important to know the process, but when it comes to the scale part, it doesn't necessary to know how to process the data on massive scale for even for a junior or a beginner, because there are a separate arrangements for the or most of the organization it has. But understanding the nature of the data, how it will be utilized, it is the person who is doing the modeling. So we should know the in perspective of the knowledge and practical aspect, but actual handling of massive amount of data is a big data processing, although it's a part of data science, but not exactly we fit into the machine learning specific jobs.
Got it.
Awesome.
Thanks.
So I guess we answered almost all the questions. There was one more I already answered in the chat. So yeah, and I guess we should be free to conclude for the day. Yeah.
All right. So yeah, thanks again, everyone, for joining session 2 of our mini series. We have 2 more sessions next Sunday and then the following Sunday. I want to thank Ajinkya for again a great session, very engaging style. I hope everyone enjoyed it as well. Also, Prakash, thank you for your industry insights. As someone who has worked in data science for many years, always good to get your perspective as well. Yeah, everyone. So we will make the recording available, send it out in email later today, so you can go back, watch it. We're always open for questions, feedback. Feel free to connect with us on different social media channels, send us an email, whatever is convenient for you. And yeah, we look forward to see you in session 3 next Sunday, 2 p.m. IST, same time, same place. And yeah, wish everyone a great rest of Sunday, the weekend, and see you guys
Cool.
next week.
Thank you guys. Bye-bye.
Okay.
All right.
Bye-bye.
Bye.